Let's come to the proving of trigo identity now. As a guide, always prove from the more complicated side to the less complicated side. There are a few techniques that you can approach, but always make use of the trigo identity given in the formula sheet when needed, okay, or when you are lost. More importantly, try not to give up, and it's always easier to express all your terms in terms of sine and cosine or even tangent, okay, so that the whole question looks simpler. Let us get started with 5a. As you can see, the more complicated side is the left-hand side, where you have tangent square x minus sine square x. What do you notice about part A? The left-hand side has two terms. The right-hand side has only a singular term. It means that most probably, you can actually express them as a common denominator. And you have learned previously that tangent is actually sine divided by cosine, meaning your tangent square can be written as sine square x over cosine square x. Like I said previously, I can make use of the technique of having a common denominator, and I'm going to do it now. Okay, after changing them to a common denominator, you notice there is a common term. And what is that common term? Sine square x. And what's left behind? Okay, now there is some decision making to be done. 1 minus cosine square x. If you refer back to the formula sheet, okay, the use of the trigo identity will tell you that sine square plus cosine square is equal to 1. So in this case, this will actually tell you that 1 minus cosine square x is the same as having sine square x. So in this case, I can rewrite my expression as sine square x over cosine square x multiplied by sine square x. And this in turn will give us tangent square x, sine square x, which is equal to your right hand side. And there you have it. We have proven the first part.